We are a bit behind schedule, but now we come to our last lightning talk for today. It's Omar Akram, and he will talk about DeskConnD Secure cross-platform IPC on the network. Please welcome Omar Akram.
Okay, so I'll quickly start and make it quick and make sure that we end on time. My name is Omar Akram. I come from Pakistan, and I come from Pakistan, and I have been part of the core developer team at Crossbar.io. It's a German company that kind of sponsors the development of Autobahn, WebSocket, and WAMP libraries. We also developed the Crossbar WAMP router. Recently, we are actually working on developing a data market that is distributed so that no single entity controls the data. So we are working with different companies as part of that project, which obviously should show something in the next few months. I've been part of the Ubuntu community for more than 10 years, and maybe the next month would actually be the 10th year when I became the Ubuntu community member officially, and Ubuntu kind of sponsored my trip here as well. And finally, I was a QA engineer at Canonical before the famous layoff that happened. So I'll quickly talk about the WAMP protocol itself. WAMP was initially defined as a sub-protocol for WebSockets. The proposition was that because WebSocket itself was end-to-end, and then you have a server and you have a client. So something that was missing was if someone wanted to do remote procedure calls, or if someone wanted to route that traffic to other computers, they would have to develop those semantics themselves. What the WAMP protocol does is it introduces remote procedure calls and publish subscribe on top of WebSockets. And it kind of allows you to be able to write responsive websites with decoupled services. So with feedback from implementers, we actually changed the protocol in such a way that now any bidirectional reliable transport could be used. So it's not really tied to WebSocket now. Any other transport could be used. Maybe we will be doing transport based on top of Quick that someone was talking today as well. So, and obviously Zeroconf is a technology that's used for service discovery and name resolution on the local network. And seems like someone disabled multicast on this Wi-Fi network. So I had to create a hotspot on my own device to be able to do stuff. I'm assuming that's due to making sure that the traffic doesn't go crazy and the routers are able to sustain that. The main thing is this is the project that I wanted to talk about. This is called DeskCon. It's your connection to it's your computer's connection to different things. Your computer could be a Raspberry Pi. It could be your desktop itself. In some cases, it could be your mobile phone, which is right now, for example, my mobile phone is connected to my computer and it's actually controlling these slides. I'm obviously not pressing keyboard buttons there. But I'm doing these RPC calls that are like these procedures are exposed by my computer. I'm just pushing them from here. This is not something like groundbreaking, or this software is not groundbreaking. Obviously, many people have done that in the past as well. But I just hacked this around last night so I could do something for this. How it started? Well, as most of the open source projects start, it started as something that I was trying to scratch my itch. Like I had some use cases at my home. I wanted to control the GPIO pins running on an Ubuntu core device on my home. I have this home automation project which kind of balances load in my home using solar power. For example, in the time of 10 a.m. to 4 p.m., I want to be able to run as much as load on that as possible. And so I wrote this thing to be able to control these GPIO pins from my mobile phone or my computer for that sense. And obviously, at a later stage, I worked in a co-working space, and one of the problem that came up for me was, in some cases, you forget to lock your desktop screen and you move away, and you have this constant fear that someone might poke into your computer. So what I implemented was I exposed an interface from a computer and hooked it to that daemon, and ultimately it was controlled by my mobile phone. So whenever I stepped away from my desktop, I could actually check my phone as that if I forgot to lock it, and I could actually lock the desktop screen. Obviously, this was working on most Linux distributions. I tested Ubuntu, and a few others. Well, LightDM was working, GDM, and a few other display managers were working quite fine. And then this thing. So I think mostly we know that if you watch Netflix on your mobile phone, when you go to full screen, it automatically raises the brightness of the device. This is something that was missing for desktops, so I wrote a Chrome extension to be able to do that. A Chrome extension would send a request to the daemon running on my desktop. It would raise the brightness while talking, not talking direct. Well, it would actually write those values to the backlight driver on my Linux-based system. So these were some of the use cases that called me to write that thing. Initially, it was all coupled together, but with time, given the use cases, I kind of broke it down into different components so that it could be reused by different people trying to implement different use cases or any scenarios that may come up from them. So at the core of this technology is a router. It's called Crossbar right now. I'm using that router. You could implement something for discovery. Obviously, I use this Python library, Python Zeroconf for discovery. So whenever this server starts on a local network, it's discoverable by other devices. And you could hook in different clients. One client, obviously, in this case, is my mobile phone. The other could be a Raspberry Pi, or it could also be my desktop. Well, there is a client running on my desktop as well. The CLI used to do the pairing. You run a command on your desktop to generate a key code that then you put in your mobile phone, which actually allows you to pair these devices for security reasons. And obviously, it's cross-platform. The technology that's being used here pretty much runs on all platforms. It works on Windows, on Linux, on Mac. The core thing, the thing that's doing all the routing and all the remote procedure calls and the security layer, that is cross-platform. And then the multicast DNS, which I already said, isn't working on this environment, but obviously it's pretty mature enough that Apple itself uses it in most of its devices, and many Amazon tablets are also using that. Well, on Linux we have Avahe, but I'm not sure if we are using it that much apart from the printing stack, but that is how it is. And okay, so I came up with this little piece of code that I wrote last night. For the most part, this is what's exposing the functionality on my desktop. This is talking to U input to send key events. So these are 4 key events that I assigned to different procedure RPCs, so which I'm calling from here right now. Obviously, there is one for stopping and starting, and then there is next and previous. This is being controlled. This is, for the most part, sending key events, the right arrow key, the left arrow key, well, actually, and the F5 and another key. I don't know which one is that. I don't remember it right now. That's page down, page up, escape, and F5 key. Okay, so this is the simplest code that is running on my computer, which is exposing this functionality. And here is the overall picture of this thing. I wanted to do like this architect of this thing. The daemon itself, which is running, which is the router, is running on my desktop. I've called it DeskConnD, inspired by LexD and systemd, the naming, obviously. Then there is an Android client. There is a Chrome extension, which is called BrightFlix, which tries to like raise, which obviously monitors Netflix.com, and whenever it goes full screen, it sends a signal to the daemon, which forwards that signal to the other component that's running on my desktop, and that raises the screen brightness. And for my home use case, I already told about the PyCon. That is also another project that's sub-project of this umbrella project. PyCon is your Raspberry Pi's connection to things. And right now, that component is only being used to control the GPIO pins on that thing, and which is producing quite a lot of saving for me as it comes to using that solar system in my home. And so this is snaps, obviously, since I mostly used Linux-based systems on my computer, so much of this is being shipped as snaps, and they are first-class citizens here. Obviously, they simplify application delivery story very much, and due to the fact that snaps are, you can use Snapcraft to build different packages remotely on canonical provided servers, you get free RMHF builds that are very essential for me to be able to run my software on the Raspberry Pi, because trying to build something on the Raspberry Pi is a resource killer, and it also takes quite a few hours in some cases to do that. So this service obviously kind of helps me do that, and obviously they are secure because U-input in itself is very dangerous to expose to anyone. Right now, I've been talking to the Ubuntu guys to be able to allow that. They haven't allowed, there isn't an interface for U-input to be accessed in a confined snap, because you are talking directly to /dev/U-input, which is very, let's say, open for key event. And we cannot afford that, because a bad actor could do lots of different things that most of the people wouldn't really want things to be. And what's next? The project obviously is hosted on GitHub. I've been doing active development of this thing for the last few months. Well, I was quite busy for the last 2-3 months, so the development pace isn't that fast as it used to be a while back ago. But now that I do plan to do most of the changes that I have planned in the next couple of months, so that it's shippable, so that many people in the community could also contribute to this project. So I invite anyone, if there is interest, to just clone the projects, fork them, report any bugs if you are able to run them on your systems, and I'll happily try to fix those. And any questions or anything, I try to finish it. And you could contact me.
Thanks, Omar, for your talk. And we still have 2.5 minutes. So if there's someone who wants to ask a quick question, just raise your hand and I will bring the microphone to you. Nobody? Okay, cool. Then thanks again.
Yeah. Yes.
Oh, there is one.
There is.
The router, where does the router run on my PC? Or?
Yes, on your PC, because that's where these APIs get exposed. So your router, as soon as the router runs on your PC, it sends its name on the local network using multicast DNS, so that other computers on the network are able to discover that. That enables easy access.
Okay, it's for the local network? Then.
Yes, it's totally around the local network. In future, there will be support for remote access as well. Like the router running on your computer will be able to connect to a remote router provided by me maybe, or you would also be able to host that. And then you could do all these calls over the internet as well. The technology is there. It's just a matter of doing it.
So, another one? Yeah, thanks again.
Cool.